Okay, so we're recording. So this is the second of the BuildOn sessions. All you participants are welcome to pop in with questions if you have any as we go. Uh, Today's session is going to be a little bit from the top and a little bit from the bottom, and I don't know how far we'll get. Let's flip through a page or two. Um, I want to stop here just for a minute. Tillich last time made the interesting comment that he hoped that he'd learn how to use Rust at work, and so I put this slide up just to address that a little bit. You know, one obvious way, Rust has a really nice foreign function interface that allows you to talk to C and C++ code, C style. It's all function level. And so, you know, one way of using it is to incrementally uh, uh, port Rust into a current application. So the model is you build a little bit of Rust and use the foreign function interface. So it's mostly the original application, and you just progressively, all the parts that you're unhappy with, you want to replace, you progressively replace them with Rust, and you get a little more performance, and you get security, memory safety and data rate safety, all those good things. Truth in advertising, I haven't done this yet myself. I'm kind of itching to do it, but I know quite a few people have, and the reports have been quite good about it. Another way to use it, Rust generates WebAssembly natively, really easy to do. And so you have the opportunity to speed up if you've got heavyweight JavaScript processing in your front end or in the back end with Node or whatever. Using the Rust WebAssembly is a way to do that. And of course, another option is to start new projects in Rust. And the tooling is terrific. I hope you've gotten a little taste of that, and we'll get a little more taste of it today. And there's lots of resources. So Rust has this reputation of being hard to get started with, hard to learn at the beginning. And I think that while there's some truth to that, it's overblown. It isn't so tough to get going. As long as you're willing to put in a little bit of effort. It's fairly straightforward. So my plan today was to talk about the text finder application itself and then focus in on text search. I don't know how far we're going to get, but I'm gonna, my model is that we will. I won't hurry things up to cram it into a given time slot. If we run out of time and haven't done everything we want to do this time, we'll just pick up where we left off the next time. Does that sound good to everybody?
Yes, Professor.
Okay. So the first thing I want to do is bring up this guy. Do you see this Visual Studio Code in the window? Is that showing up in the?
Yes, it is, with the code on the left and the terminal on the right.
Yeah, good. So you can see it. So what I want to do, this is my solution to Text Finder. And I want to run it because I want to make a point about it. So what I have here is a bunch of things to notice, but let's focus for the minute. This test2 is the name. It's really, this is my integration process, and I would rename this to Text Finder, but right now it's test2. And the command line is saying the capital P says I'm going to put in a path, and then there's a path that's moving up several levels. and a pattern. The lowercase p is a pattern that says, I want to look at Rust code, source code, and I want to look at header and implementation files of C++. And I'm looking for this text that's struct. So let me run it. So we processed 2,600 directories and 6,800 files in a pretty short period of time. If I went up a level, you would see, it would be longer. It would be a long-running process. And this is getting at the point that I wanted to make, that we want to be able to get output as we go, not just pull in all the inputs, do all the computation, and then when you're all done with that, blast out the results. Because for a lot of applications of the text finder, people will sit there and say, what's going on? Did this thing crash? I'm not seeing any output. So what we'd like to do is to see our output as we go. And it turns out that has a fairly major impact on the way we build it. So let me, no, come on. Come on, let me put this down. I don't want to kill it, I just want to put it down. There we go, okay. So what I want to do now then is think a little bit about that. So we just ran this text finder, and I want to talk a little bit about the design. I'm going to skip over most of this. You're invited to come and read it as you go. The way I've laid out in the specifications the text finder, I've partitioned into some packages: text finder, command line parser, dir-nav, text search, display. You're not obligated to do it this way, but I think it wouldn't be a bad idea for you to follow my design lead, because I want to introduce, if you do, two good things happen. One is you're going to get exposed to and deal with some important issues. And the second thing is that we'll all have a common base of implementation, and so we can ask each other questions and so on about it. We have a common basis for. So that was a package layout, and the class structure is going to look something like this. And what this is a data flow application. I'm going to come back to this in just a minute. Let me go on to the next slide that I want to talk about this structure a little bit. So, this is here just to remind us that what we're trying to do is look at what may be a long-running process with lots and lots of output, and we'd like people to see that output while it's still running. A classic way of designing a system, you might start out something like this, where you have input and some computation and do some output, and you don't see anything until you're all done with input and computing. And even if you factor that out into a more reasonable structure, so you pull out these guys into package factors, it's a little easier to manage, but you still have that same gather the input, do all the computation, then blast out the output. So what we want to do, I'm going to come back to what I'm skipping over in a minute. What we want instead is a data flow architecture. We want to set up a pipeline where the executive talks to the input processing, and the input processing talks to the compute and to the output, and that's constantly, there's constant activity going on here. I'm doing this with a single thread, but once we finish this core design, if anybody's interested, we'll go and do some multi-threading. And this architecture is beautifully set up to let us introduce some parallelism, for example, in the text searching process. we're going to go one step further, and we're going to do something called type erasure. And if you remember from OOD and software modeling and analysis, we talked about the dependency inversion principle, and that's just about the same thing. What we're doing is we're using an interface and an object factory so that input is ignorant of the exact type details of compute. To input, all he understands is he's talking to somebody who has the C interface. And the compute guy, all he understands is he's ignorant of the details of the output. All he understands is he's talking to somebody with the O interface. Okay, and what we do is this input is going to be our dirnav, and dirnav will define this C interface. Dirnav, we call it dir event. What dirnav is doing is saying, here's an interface. If you want to use my services, you implement this interface and I'll call you. Hollywood principle, don't call me, I'll call you. And it turns out that makes this guy not dependent. So instead of input being dependent on compute, compute now depends on input because input defined this interface. In reality, both input and compute depend on this interface. And this interface, we'll see, has a little factory function, and so all of the dependency inversion principles work. This is where we're going to go. So this gives us the dynamic behavior we want. We see output as we go, and this makes that a little more robust in that I can make any changes I want to compute. As long as it continues to implement this interface, I'll still build. This input will be able to use compute no matter how we change it. And the other nice thing about it is that if I make a single change here, the only thing that I recompile is this guy. I don't have to go and recompile all these other pieces. Okay. Everybody with me? Did I leave everybody in the dust?
Sounds good, Professor.
Okay, Vishtas, how do I get that? How do I get that video bar back up again?
Okay, I think there should be like a real tiny version of it
maybe
that you should be able to maximize again.
Show small active speaker video. No. Okay, got it back. So this video bar, I see it, but it's not blocking your view of my screen, is it?
Nope, it's not.
So you guys don't see the video bar. Okay, good. All righty. So the next thing I want to do is look at test cargo. That's on the next page. So you have this structure to build. I skipped over the structure. That's okay. Well, let me go to the next slide. This is a classic structure for Rust. There's some application, and it wants to build, so this is a structure to build a library. And so this is my text search. I'm going to build a text search library. And the library code resides in a source directory, and I can use the service of the library by anything that I put in this examples directory. So I can have 3 or 4 different tests and demonstrations of my library code by just putting different files in here, and they all can have mains. They all will have to have mains, and Cargo is smart enough just to run one of them and link it with a library that we're using. Okay, really, really nice facility. So let's go back and take a look at how that happens. So I'm using Cargo here in the terminal window. You see I've navigated to a directory on this machine called CSU temp, where I just build junk code, temporary stuff. I issued this command, cargo. Now, as soon as you install, if you install cargo and take the defaults, cargo will be on your path. And so I don't have to do any kind of fancy stuff to get access to cargo. I just pull up a command window, and now cargo new says I want a new package, a new project. I want you to create a directory called test cargo in camel case. I want this to support a library structure, and I want to name the application test_cargo. Now, cargo uses directory and naming conventions, and you want to follow them. If you violate them, things won't work right. Cargo is this beautiful, beautiful tool, works really easily, and all you got to do is follow a few simple conventions. So here, I built this application. What that did was that created this test cargo, and it created a GitHub repository if you want it. You can delete it, doesn't make any difference. It created a source directory, and we'll look in a minute at what's in that source directory. And it implemented a cargo.toml file, and we'll look at that in a minute and see what's cooking. So now I navigated down into test cargo, and I said make dir examples. I created this examples directory. Cargo won't do that for you for some reason, but I just manually created the examples. Notice that this is plural. And now I CD'd down into example, and I just used echo. I'm on a Windows machine, so I just used echo to create a file called test1.rs. This is a Rust file, and it expects us to have a main. Right now, it doesn't have anything but this comment in it. Okay, here's that file when I'm done with this command. So now I'm all set up and ready to pull up Visual Studio Code, and it's when I'm here in the terminal, if at this point I CD'd back up to the directory with the cargo toml file in it, and I said code dot, it would pull up Visual Studio Code. So I've got an instance of it running here, test cargo, and here is after about 5 minutes work, here's what resulted from that project, that test cargo project that I set up. I just pulled up Visual Studio Code, and what I find when you first look at it is the source of the lib has just exactly this and nothing else. This is a hook for unit tests for your library. But it doesn't write any library code. It doesn't know what library code to write, like any good wizard. So I came along and I created this little comment, lib.rs, and I wrote this code. In Visual Studio Code, I just pulled up the editor, clicked on that file, the lib.rs, I'm pointing to it, and you can't see me point. The lib.rs file, you click on that, and that, it'll come up with this. And now I can just edit in it. And what I did was I edited this code. What this statement says is, compiler, please implement the debug trait and the clone trait for this struct. Remember that in Rust, what C++ uses, the way C++ uses classes, Rust will use a struct instead. It means the same thing. I'm building types with a struct. And this statement says, please implement these traits. The debug trait allows me to use this formatting for my output. This is a debug formatting, and almost everything implements the debug trait. And so that gives you a expanded, fairly simple view of whatever it is you're displaying. There are other kinds of formats. for example, there's a display trait, and if I removed this, it wouldn't compile for this, to display this type because I didn't implement the derived clone. And that's certainly doable, a little messy to do that sometimes. The clone trait is just providing a function called clone that will make a clone object. And we'll look at that. It's one of the next things we're going to look at in just a minute. So this is a constructor. Okay. In Rust, the constructor name is not the class name. That's why they don't need function overloading. I could define a constructor new 1, new 2, new 3, my fancy constructor. Well, I could name anything I want. And for this simple class, since I have no data, this struct, I could have written this way. And now that makes it obvious. This is a struct this is a struct with no elements in it, okay? But, but instead, it's totally equivalent just to do this, so. Oops, I changed the wrong thing. Sorry. It's always risky when I start here doing code when I'm talking. I meant to do this. Okay, now it's okay. Okay, and now I have a function here. This function, say hello. This says this is a member function, so if I had any data, I could use it as self dot whatever the data name was. And I'm entering a name as a literal string. That's what this str type is, if you remember from last time. And I'm just printing it out. So, when I run it, it just built it and ran it. Okay? Everything you do is a mild expansion on this. Okay? So I could run, there's a silly little test. This is always put in here just to show you how to write a test. And it just asserts that 2 plus 2 is equal to 4. And I can run that test by saying cargo test. Says, okay, yes, in fact, 2 plus 2 was equal to 4. Okay. But, it's just showing you how to do it. And so what you will do is now you'll just have a function. You can name it whatever you want. And typically, these don't show any output on the console. Even if you have print statements, they won't show on the console. It expects to do its work with asserts. And if the assert fails, if I said 2 plus 2 is 3, it doesn't crash or anything. It'll just fail the test. Error, failed. Okay. So, and you'll see me do some of that later on. Not today, but you'll see it later on. Okay, so let's look at the cargo toml file. So this is a metadata. When cargo builds a project, it always builds a toml file. And when I just gave it the -- name test cargo, this is what it uses. Put that in the metadata. Gave me a version, and this version means I'm not ready for prime time yet. I'm in progress. And if I had dependencies on other parts, I'd put them here, but I don't. Now, here's this name. How does the test1 know about it? Because test1 said use test_cargo test Rust. So I'm importing this one type name into this scope. And so now this compiles and it works. If I left this out, cargo run, example, test 1. It failed because it says not found in the scope. It couldn't find test Rust because I didn't import it. So that's what that does. Okay. So the intent is, just to give you a little flavor of how this development process works. Let's put this down if I can get to this. Okay. So, here's that same screen we were looking at. So the idea here is that you can always go back and pull up this PDF. If you go to the sitemap and the BuildOn part, so here's my sitemap, you scroll down to the BuildOn part, here's the PDF we're looking at right now. So you can always click on that and pull it up and look at it. And now you have that, you have this stuff at your disposal. And it builds, this is a structure it built. Okay. One thing, let's take a look at this, one quick aside. This is a documentation page for a GitHub repository called BuildOn. And let's actually go to that BuildOn. Everything you see, other than the code that I just ran, is on GitHub. The web pages we're using are on GitHub. And what you see right now is BuildOn structured demos. This is helper code for step 1 and step 2 for the text search and for the directory navigator. What you'll see after we finish text search, and as we're beginning to start dirnav, you'll see my solution to text search. I'll put it here. You'll see BuildOn solutions, and you'll see text search. And then when we finish dirnav and go to command line parser, you'll see my dirnav. So the point is that you're working away, and even if you don't totally get it to work, you can go take a look at my solution and see what's the difference. Why did yours work and mine didn't work? That's the model. Okay. Now, I want to talk about, let's talk a minute about Rust byte data. I'm going to flip back to the sitemap just for a minute. So there's a block here that says Rust bytes, and there's a Rust story. Rust story is my book, my ebook on Rust. And, you're welcome to read or whatever. This is a series of very shorter little web pages, little pieces on each of the features of Rust, that some of them go into a little more detail than the story does, or have a slightly different point of view than the story does. And I think this is a really good way to kind of bootstrap yourself with Rust, is to look at these Rust bytes. What we're looking at right now is the safety thing is here, and the data, here's data. That's what we're going to look at right now. So this is the data. And I'm not going to drag it, it'd take us a while to read through all the text. We're not going to do that. What this page deals with is, what does bind mean and how does it work? What's copy? What's borrow? What's move? What's clone? What's mutate? And I'm going to explain this mostly by just looking at a couple of diagrams. Binding just means that I'm associating a name with a value in some location. And I can bind a name to another identifier, so I can let j equals k, okay? And primitives are copy types. That makes a copy. Strings are move types, and so if I bind t to the string s, the ownership of s has moved to t, and s is now unavailable. That's the gist of data handling in Rust. It really is fairly straightforward. Let's see what it means. An assignment works the same way. This is, if you will, this is like copy construction, and this is like copy assignment. So a copy type is a primitive or a literal string or an array of primitives or things like that. They're things that occupy a contiguous block of memory, and the way copy works is it just does a mem copy. It takes it, blasts these bytes into this location. No analysis, no computation. It's just bytes to bytes, really fast. And that was a smart choice. They're trying to make a really fast, code that really runs quickly, and so this type works really nicely. Now move. When I say t equals s, this is really quick too. Here's what happens. When I move, so assume that this guy isn't here now. So I have the string s. He has a pointer to some allocated memory. He has a length and the number of bytes in a string, and he has a capacity, which is how many bytes of memory is allocated for this. And when I say t equals s, let t equals s, what I did was I created the same block. What I really did was just blit this block down to here. So it has the same pointer value, so this guy just points up to here, and now this guy is made invalid because we don't want two guys pointing to the same memory allocation, because when there's only one owner of data, when that owner goes out of scope, he deallocates the memory. If I had two guys pointing to the same memory, first one goes out of scope, deallocate, second one goes out of scope, crash. So moves, and this is really fast. It was a question?
Yeah, Doc, I was just going to comment for perspective. So, when you contrast this with the C# or the Java model, this is, the semantics here is very different, right? Because in the Java model, you're going to get a reference type of account going on. You're going to have multiple This is a direct contrast to that, where you're not.
In the managed languages, C# and Java, the owner is not the object that you created. The owner is the garbage collector.
Yeah.
Treat the term owner, meaning that entity that releases the code at some time.
Yeah.
And that means the owner in C# and Java is the garbage collector. You have one owner for everything. Here, each element owns its own data. Each string owns its own data, and when it goes out of scope, just like in C++, when it goes out of scope, a drop function is called, which is absolutely equivalent to the C++ destructor being called. Piece of cake.
Thanks, Doc.
Thanks, Mike, for pulling that out of me. So, and here's what clone means. So when I clone something, so if I say let t equals s, s becomes invalid. If I really want to make a copy, I can. I say let t equals s dot clone, and now s stays valid because somebody's phone is going off. It's probably mine in the other room. Come on. Thank you. Hang on 1 minute. I just got a call from my doctor. I think that means that the coronavirus vaccine is available. So So I'll have to call him back as soon as we're done. So now I could say t equals s.clone, and now s remains valid because the clone's resources got moved. So here, when I make a clone, I'm creating another one of these, and now I just copy this. So they each have their own allocation. So now when I bind t to s.clone, I'm binding it to this guy, and now this guy becomes invalid, but the original s stays valid. Really sensible, easy to understand once you see the picture. So, okay. So that data, you wanna keep that up in the frontal cortex. That's a really important, that has to become second nature to you. Now, I want to talk about safety. On the way, I'm going to pull up something I call animation. This is something I put together that uses the Rust playground. We saw a little bit, I showed you a little bit of the Rust playground last time, didn't I?
Yes, you did. You did show it to us.
Okay, good. So what I want to do is I want to show you some C++ code that has a memory fault. Actually, two different kinds of memory faults. And there is a C++ playground as well. It doesn't work quite as nicely as the Rust playground, but it's fine. And you can't store stuff in this playground without signing up for their site, and I didn't want to do that. I'm signed up on too many sites as it is. So I just put some code, the code I want to demonstrate for you in a GitHub gist, or, here it is, the same code in a drop-down. This is the code we're going to look at, but let me just pull up the gist and copy it. Come on, I want the, come on, I want it all. Good. Control C. Okay, so there's my code from GitHub gist. And if anybody, you're interested in how that works, just stick around at the end of the meeting and I'll talk about it a little bit. So let's pull up the coding playground. Now let me run it, and then we'll talk about it. Notice the process ended. It's got data problems here, but the process ended just fine. You'd never know it. So here's what's happening. I got a vector v of integers. I reserved capacity for 3. And now I'm pushing back 3 integers, 1, 2, 3. So I've filled up that capacity. And I show it. Here's the vector 1, 2, 3. Now I'm creating a C++ reference. This is C++, remember. I'm creating a C++ reference to the second element of the vector. So its value is 2. Okay. 1, 2, 3. 1, 2, 3. And notice that the address of v1, this guy, whoops, is exactly the same as the address in the reference, just as you'd expect. Of course it is. Now, let's push back one more thing. Seemingly nothing happened. Now, the address of v1 has changed, of course, because it reallocated. So this was 34, now this is 54. But look at the reference. It's still pointing back there, that old memory. Dangling pointer. And I can read it. And I get a value. Okay, it happens to be 0 because I just happened to hit an area of memory that was initialized to 0. But I could sweep this into my program and compute on that for half an hour and have all these, bogus results and never know where it happened. I'm going to do another thing. I'm going to come in here. I'm going to create an array. And now notice I'm going to step 1 over the end of the array. not just less than 3, but less than or equal. So I step 1 over to the end of the array. So here I am, printing out its contents, 1, 2, 3, garbage. C++ very happily let me do that. Now, in fairness to C++, the modern C++ has lots of idioms to avoid all this. You absolutely can write safe code, memory safe code in C++. I would use the range-based for loop down here, and I can't step over it, because I'm defining it in terms of the begin and end of the collection. And if I used an iterator instead of a reference, this would have thrown an exception here, and I wouldn't have been able to read and write the memory. The issue is that in 100,000 lines of C++ code, you're going to slip once or twice or 3 or 4 times, and you're going to fail to use the appropriate conventions, and you're going to have in these few obscure places those bugs that take you forever to find. If you ever, assuming you even know that they happen. Now let's go and see what happens with Rust when we do the same thing. So I'm going to attempt to do undefined behavior with Rust. So this is exactly set up the same way. I'm using floating points instead of integers. I don't know why I did that, but I did. Here I'm making a reference to the second element of it. Okay, so it's a floating point 2. And I display it. And now I do a push. And so what happened here? And display it. Well, let's try to compile it. So can't do that, guys. And it's telling me exactly what's going on. It says at line 18, I made an immutable borrow here. This is where I made this reference into the internal of the vector. And immutable borrow appears here, v.push. I'm not allowed to mutate. So when I borrow from that vector, the vector's not allowed to mutate until that borrow goes out of scope. That's what gives me safety. Okay, so, and it tells me, the immutable borrow later used here. The point is, if I don't use it, it'll let me get away with that. What counts is not that you followed all the rules, but what counts is whether you used that bad, declaration or not. It's the using. It used to be that if you declared it, the compiler, it wouldn't build. But the compiler team said, hey, a lot of programs that are just fine, don't compile simply because that was never used after that. So let's convince ourselves that that in fact is the case. So I'm going to come here to this place where I'm using that reference, and let's comment it out, and now let's run it. And it ran fine. Now let's leave that comment out. Let's go to the, here I have a little iteration over that vector, and let's change this to 5. So now I'm stepping off the end of that vector, and let's try to run it again. Panic. So I thread main panicked at index out of bounds. So what's going on here is this is something that's determined at runtime. Most of the safety analysis is static analysis. You want to have it static. You want it to that analysis to be done at compile time, not at runtime. But there's some things you just can't tell. Something like this case, how did it know that I was going to put 5? In truth, it probably could have analyzed that, but that's a little more work than the compiler wants to do to see that I did that. I'll get into that in a little bit. So, but anyway, the point is, I can never read and write memory I don't own. I might have a panic, which is an orderly shutdown. Everything is being properly deallocated. You know, all the valid objects are being dropped. So nothing bad has happened to that state, and whatever thread was running this then terminates. And I could restart the thread, you know, and whatever. So, you know, now let me put this back to 3 so I don't, whoops, well, it'll be 3. So anyway, what we saw is what C++ allowed us to do without complaint, Rust will not let us do. Okay? Mostly by static analysis, but occasionally by a runtime. And this runtime check is probably something really simple, like, you know, what's happening when you get the value out of a vector, the vector has to give you that value. And so what's, you know, when it's doing that giving, it's checking against, you know, is it outside my boundary? And if it is, it panics. It throws a panic. By the way, you can catch panics just like you catch exceptions in C++. I've done it. I've got some examples of that. The Rust community doesn't like to do that. They have all this nice error handling to try to avoid those from ever happening. So the mental model in the Rust community is don't panic by intentionally handling all of the error sources. And that's a good strategy. I've grown to like it a lot. I'm not going to talk much more about this. I just want to say that this animation thing is something I hope will be useful to you. I have a little demo of functions, a little demo of structs, iterators. So here, for example, iterating over collections. Here I'm iterating over arrays and string operations, and I'm using some non-ASCII characters and using some filters on an iterator to pull out the numeric part of this, and you know, vectors and vecdex, especially the hash maps. It's worth taking a look at this. This entry API is quite useful for hash maps. I'm not going to, you know, we don't have time to talk about that now. But the point is that there's a lot of these kind of examples, you know, function structs, iterators and collections, traits and generics, enums, error handling, string conversions, lifetimes. Anything you certainly need for text finder, I think you'll find here. I think you'll find help. So it's a good thing to know. How do you find it? So you say, okay, sounds great. You told me about it. Do I have to pull up your dumb PDF in order to get that? And the answer is no. If you go to the sitemap, here's Rust animations, and this is what we just looked at. Okay. So, and these things, these grayed out things, I don't have anything there yet. You know, stuff I'm going to put in eventually, but haven't gotten to it yet. Oops. Okay, how we doing, guys? Pace okay? We making sense?
Yes.
Yes.
Okay. All righty. So I'm kind of bouncing back and forth a little bit between Rust and Cargo and the text search. Let's look at text search a little more. So in each of these, I have one for text search, one for directory navigation, one for command line processing, and one for the executive and display. And in each of them, I put the text finder specification. If you go here to 0, this is where I developed that spec. And I just put a little capsule summary of the spec. So it's always here. You can see, you know, what the specification for this overall thing is. And I've given a little spec here for text search. You know, I've laid out function signatures and stuff. Again, you don't have to follow them, but if you do, then it'll be easier to compare your code to my solution and easier for you guys to collaborate with each other. And I hope you do. One of the reasons I put up this Discord server is so that you could, get together with a buddy and talk about anything that puzzles you. Okay, and so I made some notes about it. A bit about the tooling, and there's a link to the tooling page to help you get started if you need it. Here's the starter code. And I gave you an awful lot of help in the starter code for text search. My model is you're struggling to get your toes into the ground on Rust. So let's make this one, I'm going to give you a lot of help here, and looking at what I did will help you get your arms around Rust, and so you can spend more time learning Rust than you actually spend building this part. This is just the display part, which is a mock. This is just a test mock for the display part. Here's the finder, which is the class. So here's the text search, and this is the class inside text search. So right now I have these two classes in here. This class will eventually migrate to display, but right now it's here. And without pouring through all the details, you're implementing with Finder, you're implementing dodir and doFile. And dodir is just saving away the directory. And virtually everything you need to do is right in here. doFile. So what happens is the directory navigator gave you a name of a file that matches one of your patterns. An RS file or a CPP file or an H file or whatever it is you ask for. And now your job is to bind that path name to the directory. So this guy's saving the directory name in self.dir. Notice how I'm using the self parameter. Okay. And so here I need to bind self.dir to this path name that was sent in to make a fully qualified path name. Can you see me? Can you see the videos at all? You can?
Yes, Professor.
You see me holding up my finger? Okay.
Yeah.
I'm sitting here making gestures and I want to make sure you can see them. So, your job is just to bind those together, attempt to open the file, and then send that information on to out. Out is genout, okay? It's just a data member for now. And so you're just going to send, so what I do is I send the file name and the source text that I'm searching, just so genout knows, because it's possible I would change it in midstream. And if I found it, I send out true, and if I didn't find it, I send out false. And I want the output to know every file that I processed, because I may want to tell it the search text is struct, and I want you to give me every file that doesn't have that search text. This is an easy way to do that. Okay, so really your job is to implement this function. Sounds easy. It won't be quite as easy until, you get through the hurdles of the compiler, but, not that bad. And, there's some references here. So tooling to get stuff up and going. File system, this is the main guy you want to look at. Okay, the file system. And what I would suggest is you look at my animation first. The first thing you look at is the animation. I intended to put links to the animation here and I forgot to. So, when you got to figure out how do I open a file, and look at the error handling, because you got to deal with if that file doesn't open. Now, really, in truth, not opening is not an error in this case, because what we want to do is what we're saying is, if I can't open the file, the answer is false. If I can't open the file, the answer is that file doesn't have the text as far as I can tell. You could argue, is that the right design decision to make? Maybe I should have changed the search text to couldn't open the file. You could do any of those kinds of things. But anyway, your job in text search is to implement this do file function. And I think you'll find it works just fine. Now, so you say, how do I get that? Well, I can just take this code and select it, Control C, and I can paste it. I can open my library file with Notepad, paste it in, save it. Okay, so it's also available to you from the repo. So let's go up to the repo and the BuildOn code.
Professor, I have a query over here.
Yeah, 1 second. Let me just do this one thing and then I'll answer your query. So now, here in the BuildStruct demos, what I can do is, I have this repository BuildOn, and you can just clone this repository. You'll get more than what you need, but you'll get all that sample code to start. Okay, there's a question.
Professor, I was just wondering, are we supposed to implement the search functionality, or is there an inbuilt functionality to search for the text?
You have to build that in.
Okay.
So, but if you look at the file stuff, I gave you an example that does that. Let me get back to where I was. So now let's go back to anim. Testing file open, write, and read errors. Open file for read. Open file for write. Read file IO to string. So what I did in my application is I read it to a string and I just searched the string for the text. Okay? Did that answer the question?
Yes, Professor.
Good.
Thank you.
Okay, you bet. Will you remember how to find that?
Yes, Professor.
Animation, remember this Rust animation. So, let me just go back to on any one of these pages, if you hit H for help, that takes you to the sitemap. And so, you just go to the sitemap and here's Rust animations and here's the features. Okay? So if you can't find it, go to the sitemap because it's there. Okay. You guys have the ambition to go a little more? Okay. The only yes I got was a nod from Tillich, so
Yes, Professor.
good. Okay, so I want to talk about safety. We've already looked at undefined behavior, and safety is all about avoiding undefined behavior. So this again is a Rust byte, and so you'll find this in the, if you go to the bytes in the sitemap, go to bytes in the sitemap, safety is right here. Okay. So I'm going to talk today just about memory safety. Data race safety basically uses the same family of ideas I'm going to talk about right here, but it would take us too long. If our enthusiasm lasts and we decide to do the parallel search extension, then I'll talk all about safety, data race safety, okay? So memory safety means that a program cannot read or write memory it does not own. So memory safe code cannot construct uninitialized references, unlike any of the other languages you've used. You know, C# will let you do a null reference. So, cannot allow references to become invalid due to a reallocation of memory by the referand. This could be caused by a vector with a reference to the interior reallocating, just like we saw. References cannot outlive instances they reference. This is a lifetime issue. And Cargo is managing that for us. I'll come back to that point in just a minute. Cannot read from or write to memory accessed by indexing beyond the size of an indexable collection. Doesn't say we can't index past. You saw that we can, but you can't read it or write it, because what happens, panic prevents that reading and writing. It panics before you ever get a chance to read or write. So somebody trying to hack your code will never get the chance to read that, read that memory and write into it, a jump to to his code location. Now, that could get translated into, it's almost equivalent to no shared mutability through references. We've already seen that. No shared mutability through references. Now, this is a very strong condition. And safe indexing we already talked about. This is a very strong. Let me show you how strong this is. Suppose I wanted to build a graph class. And the normal way we think of doing that is we just, we tie vertices together with references. Rust is not going to let you do that. Because here I have this node 0 has two parents, and either one of them may want to mutate its value. That's shared mutability. And Rust says, you ain't going to do that. So does that mean I can't build a graph class in Rust? The answer is absolutely not. It does not mean that. What it means is I can't do it with references. I can move each of these vertices into a vector, and then I can use vector indices to form relationships with my children. Now, this works because indices don't become invalid when that vector reallocates, because the index is just an offset from the beginning of that vector's memory, wherever it is. So when it reallocates, the index still points to the same thing. Even though it's a different place in memory, it's still pointing to the same entity. So that's perfectly valid. So I can build a graph class just fine this way. In fact, I did this in C++. I'll say another word or two about that in a minute, okay? So that's why I'm very careful to say no shared mutability through references. Indexes are fine. Indexes never give you this undefined behavior. I mean, I can index off the end of the array, but then I'll do a panic, so I still won't get the undefined behavior. It may not be correct, but I don't get undefined behavior. I don't allow data to come into my program, or I don't allow data to escape from my program and going into some other process through that flaw. And this works like a charm. I built a C++ directed class exactly the same way. And the reason I did it was not because C++ wouldn't let me use references to tie together these, or pointers, to tie these vertices together, it definitely would let me do that. But as I looked at it, I started out with a design that uses pointers. And I decided that it was very difficult to get that to be truly safe. I could always come up with a condition that would cause unexpected behavior. And so I eventually migrated to this format, and it worked beautifully in C++. And basically C++ wasn't forcing me to use that structure. I forced me to use that structure because I could see that this one wasn't gonna be reliable. At least I couldn't account for all the possible cases where it might be unreliable. And that's exactly what Rust is doing. But it's doing it by construction, not by convention. It's not saying, okay, you should do this. It's saying, you got to do this. So be aware that this is a very strong condition, but it's not a showstopper. You may have to readjust a little bit the way you implement a program, but mostly you don't. It's fairly rare that this happens, and I'll try to explain that in a little bit. There's some rules about, here's the rules that you think about when you're writing code. This rule, while it's nice and compact and a good mental model, these rules are, what the compiler's error messages are going to talk about. There is only one owner for every data item. Ownership can be transferred. Ownership can be borrowed. Now, here's the constraints. Any number of readers may have access to a data value simultaneously. Writers get exclusive access to the value. No other readers or writers. And a reader is anybody that's not mutable. A writer is anybody that's mutable. So it's the original data type, like a vector, or any reference we make to the interior of the vector. Now you say, gee, that's a lot to keep track of. How am I ever going to keep track of all that stuff? And the answer is you don't have to. The compiler does a beautiful job of keeping track of that for you. But you don't wanna just write out all kinds of code that constantly causes you errors. But if you write every now and then you write a line that doesn't satisfy, you don't have to think about that critically every single line you write, because the compiler's it's keeping you honest. It gives you these really nice error messages. So it truly is an oracle sitting at your elbow helping you. When you first start, you're fighting it. You hate it. It's awful. But very soon, it's a friend. A stern friend, but it's a friend. Okay. There's something called non-lexical I call them filters. That isn't what they call them, but non-lexical analysis. And all that means is, you remember back when I was demonstrating the attempt to do undefined behavior, I showed that if I remove the use of that mutable, even though I declared both a mutable and immutable reference to this vector, if I didn't use the mutable reference, it would compile just fine. Even though I declared it, it's the use that's illegal. And that's really what this says. It's the use that's illegal. When just before Rust turned into version 1, they didn't do this. As part of becoming version 1, they implemented this non-lexical scoping. And it made life a whole lot easier. There's something called interior mutability, which is really the static analyzer can't tell. You're not really breaking any of the rules. You're not sharing mutation, but you can't tell that. It looks from a static analysis like you are, but just the way the program evolves in time, you're never doing it at the same time. That's what interior mutability gets at, and it's really mostly used with concurrent programs. So the mutex, you're using a mutex, and that's preventing you from simultaneously mutating. And so Rust is very happy with that. So you're using the same rules and a very cleverly designed mutex. And when we talk, if we do the parallel processing part, we'll talk all about that. Very clever design of a mutex that lets these rules apply, and it really is easy to write threaded code that doesn't have any race conditions. The gist of it is you can't write threaded code in Rust that has data races. It won't let you. Now I want to do a little mental model for you. I tried this on Mike and he didn't like it. Let's see how you like it. So this is just a thought experiment. Schrodinger's cat, okay? So suppose that we map all program activities into the XY plane. And I've shown a slice of that plane. Now, this would map it anywhere, but this is just a slice of the plane. It's in this plane that all the program activities reside. And I have a boundary between activities that are unsound and activities that are sound. Everything to the upstream side of this boundary is sound. Everything to the downstream side of that boundary is unsound. The problem is that evaluating code exactly, are you safe or not safe, is an intractable problem. Think about it this way, as we get closer and closer to the boundary, things take us a whole lot more time to evaluate whether or not which side of the boundary they're on, and some parts of it go to infinity. It'd take forever to decide whether that construct was safe or unsafe. So that's impractical for a compiler. What Rust does is it takes this simpler static analysis, no shared mutability, and it draws this barrier. So everything to the upstream side of this boundary compiles. Everything past this soundness boundary is unsound. Everything in this valley is sound but won't compile. Rust chooses to reject some safe programs to ensure that it rejects all unsafe programs. It's impossible to reject all unsound programs and accept all sound programs. It's an intractable problem. Compiler would never terminate. So we have to have a simpler condition, and that's what this no shared mutability condition really is. It sets this easy to compute, low-level boundary, so the compiler doesn't take a whole lot of time. And this, as long as we're here, cool. What happens if our program happens to fall into here? Our graph, the way we originally thought about it, fell into here. And the answer is the Rust library types like vector and vecdec and hash table have unsound blocks because they are working in this area. A vector clearly doesn't satisfy those no shared mutability. A vector has a reference to its internal memory, and it'll happily hand you out a mutable reference to some interior part of it. Clearly violates those rules. But the way they designed the vector, the vector will not mutate even if you ask it, it will not mutate if it'll fail to compile. If you ask it, once you've asked it for a mutable reference, it won't mutate. Once you've asked it for any kind of reference, it won't mutate. And so it handles this code that doesn't pass the simple criteria with unsafe blocks, very carefully crafted and vetted unsafe blocks wrapped in safe wrapper. And what happens is your programs are just using these types. So you're walking in this valley of uncertainty a lot of times and you never know it because you're just using the standard Rust types. Cool. That's exactly what happened here. I'm really walking in that valley right here because I'm using a vector. Cool.
Yeah. So, Doc, I retract my statement earlier about not liking that. Now that you put some words to it, I think it's quite clear, and I appreciate that. So,
Okay.
so thanks.
Well, good. Some of you may have to look at it 2 or 3 times and ask me again about it some other time. But anyway, I like that model. The idea here is not that you use this to guide a statement that you're writing right now in C# code. You use it to understand why Rust does what it does, and it gives you a flavor of how you got to use it. It's that mental model in the background. You never apply that mental model exactly, but it informs your decision about the code you write. Okay. And I have some, this just talks about the same thing. I just said all this stuff. I have a few productivity tips you might want to take a look at. I'm going to skip over them in the interest of time. So we looked at anim. Don't forget anim. I really think this will be a help. I'm hoping, if it isn't a help, you let me know. But, it's got little tiny bits of syntax. It's helped me because I can't always remember. I'll forget. What's the syntax for the hash table entry API? I don't remember. But all I got to do is pull this up and, iteration collections, and I click on this, and there's the entry API. Enough to explain what's going on. If I come down here to at the end where I'm using the entry API, I've got a little, let's just run it. So here, I've got a little map that has 110045. I did this intentionally, believe it or not, 22, just to show you that you could change how easy it is to change the value, okay? Basically what you do is an insert, unlike some other hash tables, an insert in this Rust hash map. If the key already exists, it just sets the value of that key to whatever you've said in your insert. No fuss, no muss, no bother, just quickly does that. Now, there's this entry API that lets me, I can say entry key, and that I expect to give me something like this. Okay, key value, that's an entry. 0, 1, that's an entry. But what happens if I apply a value that it doesn't have? So here, let key equal 42. If you haven't read The Hitchhiker's Guide to the Galaxy, you have to read it. Okay. Why 42 is such an important number is explained in The Hitchhiker's Guide to the Galaxy. But anyway, so my key is 42. Clearly, I don't have it in this map. Entry, okay, and now I print out the entry, and what it says is entry, vacant entry for 42. Cool. So this is an enumeration. Vacant entry is an enumeration. Occupied entry is an enumeration. If it's occupied, it comes back with an occupied entry with the key and the value. So here I say if let entry occupied. So if it's vacant, it won't pass this test. But if it's occupied, if that's true, this is a matching. I'm using the matching scheme. So if occupied entry is equal to the entry that I got here, then I print out the entry, and now I can say entry.key, entry.get. Key gives me the key value, get gives me the value. So I don't remember how to do that. If I haven't used a hash map in the last day, I won't remember how to do this. But it's here in the point is it's here. There's lots of stuff like that. So wouldn't be a bad idea sometime when you're bored and don't have anything else to do. Just click on a lot of these and get an idea of what's here. And I expect this to be growing. Basically, every time I can't remember a piece of syntax, I plan on putting it in here. Okay. I want to bring you back to this Rust bytes. This is the documentation page. So almost everything is in a repository in this Rust. All the bytecode is in this repository. Here's this byte list. So let's just pull up. Here was that starting thing that we looked at. Okay, we looked at that last time. And the point is that bytes here is a little, here's all the stuff. It's you're in any byte. It's really easy. You want to look at data structures. There's the byte for it. You want to look at conversions. There's a byte for it. So when you're trying to figure out how something works, these bytes are a good way to do it. You could go to the Rust story and read through the Rust story, but the Rust bytes give you a pretty quick and easy way. The Rust story, also has a menu. Here's a chapter. So for example, libraries. If I click on sections, these are all the sections of this library. And so I talk about the standard library as a whole, the collections in the library, the collections library, the IO library, the file system library, the TCP stream library, the thread library, and so on. These are all time date. These are all standard libraries. There's a couple of them that I haven't done anything with async yet. If you go down to that, you'll see sections of placeholder awaiting some construction. So code experiments is very like the NM. There isn't a good way for you to add something to NM yourself because the entries in NM are links on that web page. And this is a static site. GitHub hosts a site for me, and GitHub will only host static sites. So, you can't add to it, but it's really easy to do. If you just open up Notepad, and let's open up Notepad. And now if you pin it to your taskbar, now I can put a link here. So let's just go I can store links in it, and I can store the GitHub links. I'm sorry, the playground links. So here, if we go to NM, this is just a basic playground. Now, I can I not? I thought I could, well, maybe Notepad, I guess Notepad was the wrong tool, but any one of those, Notepad, Notepad++, for example, I know you can put links into it. Probably I could put links into it if I change the settings here. But anyway, you know, or OneNote or whatever you want, you can save a link to the playground, and then you can just paste in whatever, you know, whatever code you want to work with, and then save that link. You know, just go and make a permalink. So here, if I wanted to save this link, I just go to share, permalink, and now I have on my clipboard a link that will always bring Playground up with this code in it, so I could paste that into it's a long link, but anyway. All righty, are there any questions? I have questions for you. So who all is here? Some of you guys just turned off and went away, or are you here?
I'm here, Professor.
Yeah.
Okay, good. You just turned off. So, how was this? You know, did we do okay? Did this make sense for you? It's okay to say no. I'm confused. Went too fast. How many think it went too fast? How many think it went too slow? Neeper, did I go too slow?
No, I think it was.
Neeper, did I go too fast?
No, I think it was okay for me.
Look me in the eye and. Okay.
Some parts I think I need to go back and read again.
Yeah, well, that's
But,
okay.
yeah.
Yeah, the point is that if I go way too fast, you're just totally confused, and it's a negative.
Mhm.
I didn't help, I hurt. So what I wanted, I don't mind at all that you got to go back and look at stuff again. That's fine. Truly expect that's the case. If that isn't the case, I'm not covering enough ground.
But I think I got the safety point from the vector example.
Okay.
Yeah.
Okay, good. So feel free to use the Discord server. Does everybody have an account on the Discord server now?
Yes, Professor.
Feel free to send in questions. I really like to see some of you collaborating together. You know, some of you guys you went through the program together. For God's sakes, be buddies on Discord, and you can do direct messaging just between the 2 or 3 of you. Perfectly, works just fine. It's easy to set up a little small group of however many people, 2 or 3 or 4, and just those people will see the messages. And that's a good thing because, I don't want the Discord questions to blossom with, 10 times 25 people, 250 questions would be way too many to deal with. So if we could keep some of those into private collaborations, that would be cool. Perfectly welcome to ask questions in the question channel. That's what I meant it for. But I would encourage you to pick some buddies and work on some of this stuff together. Any I'm about ready to quit. Any final comments or issues or whatever?
Nothing from the session today, Professor, but I just had a question based off of the suggested reading and the videos that you suggested the last time.
Okay.
So while going through, I noticed that they use the word self, one with a small s and another with a capital S, and I found that a little confusing.
They use the word what?
The self
Self.
in
Yes.
the
So
code.
yeah. So self with a capital S is the type. It means my type.
Okay.
Self with a lowercase s means me, my instance.
Okay. All
So
right.
lowercase is an instance, uppercase is a type.
Okay, thank you.
Okay.
Yeah, I found that part a little confusing.
Yeah. Any other questions?
So
Oh,
Doc,
no,
just, oh, sorry, whoever is going there, I apologize.
oh no, I was just saying nothing else. So please go ahead.
Okay.
I was just going to comment, Doc, for next time then, or is the plan to look at, so work on text search and then the plan is to
Yeah,
kind of
work on
review that?
text search, and if we're ready, so if I get the sense that we're really ready to move on to DIRNav, then I'll present my really quick view. I'll put up my uh, text search code and talk about it really quickly, and let you ask any questions about your code or my code, and then we'll go on to DIRNav next time. If my sense is that we really aren't ready to do that, we won't go to DIRNav yet. Okay. We don't have a semester boundary that we gotta satisfy. So we don't want to drag this out and waste everybody's time. We want to make it as efficient as we can. But if people aren't ready to move on, we won't move on. Surely, when most of the people are ready to move on, there's maybe one or two people that aren't ready to move on, and vice versa. But in which case we will move on, but try to give some extra help to those who weren't ready.
I had a other thing, Dr. Fawcett. So
Yeah,
when I watched the YouTube video that you had shared from John,
Yeah.
there was a lot of like he kept bringing up that no GC pause, no GC pause. I think your example earlier actually made it really clear what it means.
Good.
Because we are dealing with this issue where we run into GC pause because of like a lot of compute that happens, and you have no control over like when GC will free some memory up
Right.
and things like that. So it's
Right.
always variable, and it brings unpredictability in the system versus this Rust model of actually just everything is
Yeah, it
by
has all the
one owner.
advantages of C++'s RIAA. It is RAII, resource acquisition is initialization, the scope-based allocation. So my view, I think Rust, once you get used to it, is a little bit easier to use than C++. It burns my mouth to say that. I wrote my first C++ program in 1988. That was 30 years ago. My God, 32 years ago. And I've been writing Rust code for 1 year. 32 years to 1 year, and I feel more productive in Rust than I do in C++. C++ is fine. I love it. Great language, but Rust to me is the next evolution. It's just a really nice. So if I were in, whoops, I pulled the wrong thing. If I were in the if I were in the C++ camp, I would. I don't know whether I would be worried or I would help all my users migrate to Rust or what, but so good. Did you like the video aside from,
Yeah.
he's a really smart young man, and he does a nice thing. He does a series of YouTube videos called The Crust of Rust, and they're all good. They're intermediate. None of them are beginning, but they're intermediate, and he does a great job. So you might want to look at that.
Yeah, because there is the other side. Like we are not C++, but mostly everything is in Java. So the direction a lot of folks take is they keep experimenting with different GC algorithms and all that.
Yeah.
And I think one way of looking at it is how can we just eliminate GC and simplify the system?
Yeah. I think Rust is managed by being very clever. They've managed to eliminate the garbage collector and its problems and still get memory safety. So, the penalty is that you have to do there's really two penalties. One is things compile a little slower because the borrow checker has to run at compile time. And the other is that it takes you longer to get things to compile. Even after a year's writing, it takes me a little longer. But the upside of that is it takes, I spend much less time debugging. Once the program compiles, it's pretty close to working. Not a guarantee that it's logically correct, but it's pretty close to working. So, you know, you don't spend those hours and hours and hours trying to find some obscure, you know, why isn't the answer the way it ought to be because I allowed some bogus data into my program, or, you know, where the heck is that race condition coming from? You know, so, yeah. So you had asked originally, you had made the comment in last time to look about hoping that you would get some view of how to use Rust at work. And I did that, you know, that opening slide, this slide. This one, you know, doing piecemeal upgrades, you know, for companies that have big running systems, that might be a really good way to do it. And another thing is using WebAssembly. I didn't show you that. Let's take a quick look. And here, if you look at this, I can generate assembly. You know, God help me, blah, 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 but you can generate it, you know. So if you have some small part of your code you want to optimize, you can, you know, make that tiny part and see the assembly. You can see, if you want to build WebAssembly, you know, you can see what the WebAssembly looks like. I haven't done any WebAssembly yet, so I don't have a clue about what all this means. But the point is that you can see stuff. It's you know, it's showing you, and you know, you can see the LL. So one other thing about that is Rust uses LLVM. And what that means is I think that it's going to be almost universally link compatible with C++ and C. And as long as that's the case, you know, I can either write out to or call into Rust code from an existing program because I can link to it. You know, as long as that program has a C interface or. Okay.
Yeah, I think John also talked about some library which can actually build wrappers on top of even existing C++.
Yeah, there are some. I have, so that's something I meant to talk about a little bit. There are a lot of crates. If you go to crates.io, it's gazillion, you know. So, you know, there's 55,000 crates. And you know, there's a nice, I think it's libs.rs. No. Okay. This isn't the right address. I don't remember what it is. But anyway, there's a nice breakdown of all those, you know, all these crates by category.
Yeah, I think it's,
so it's very
LD.rs.
accessible. There's an issue with this, though. That is that, for example, there's a very popular crate called SERDI, which is serialization and deserialization. Lots of people use it. The issue here is that SERDI uses other things. What you discover is that you use a crate, and now suddenly you might be using 50 crates. because that crate depends on those 5 other crates, which depend on, more crates. And the question is, are they all good? Are they all free of unsafe blocks? Are they well written? I think the most popular ones have been looked over by the Rust community very thoroughly. And so the answer is, yeah, it's probably a safe bet. But, I would be a little careful about using some of these newer ones. Okay. Now, John Jengset recommended these crate wrappers for the FFI, and he's smart. He's used a lot of Rust. He's written a lot of Rust, and doing it for his doctoral code for his doctoral dissertation. And I would be inclined to, tend to trust that. But you got to go into this. There's many, many things available, but you got to go in open-eyed when you do that. That's my only remark. If we decide, if our enthusiasm sustains, I hope it will, we'll extend Text Finder in 2 ways. We'll add regular expressions to it, and we'll do the text search concurrently. When we do the regular expression, I'm going to use a regular expression crate from crates.io, and you'll see it pull in other stuff. And so you get a clear picture that, hey, it's just not regex that we're using, it's regex plus the thing that regex is used. And you have to build all that. So.
Professor, I have another question about, I think the text search part that you mentioned. You said that the way you were doing the search is you read the contents of the file into a string and then performed a search on the string. Now, what if there are binary files in the search path? How would we?
It does no harm at all. It reads just fine, doesn't throw any errors, and it might find, if you read a PDF file and the PDF happened to have struct in its text, you'd find it.
Okay.
Okay, so it does no harm other than wasting your time. But, so you probably don't want to put .exe and .obj and that sort of stuff in your paths. And it could be, but, if somebody had did a wacko thing like make a .c file, a binary file with an extension .c, you might read it, but it does no harm.
Okay.
Other than burning up, some CPU cycles. Let's have a little fun. Let's see if we can prove me wrong. Whoops, not the one I wanted. Okay, so let me come down here. And I'm going to change this to OBJ. Let's just change it to exe. No harm.
Okay.
There were some exe files there. By the way, I'm hiding a lot of stuff from you. So here, if I said capital H /true, meaning, I gotta obey the syntax, meaning, false, meaning I don't want to hide directories that don't have matching files.
Doc, is your switch backward H/? You want /H, right?
I want /H. Thank you, Mike. You're keeping me honest.
There you
Okay.
This is why you don't want to wait till the final end to show your stuff, okay? That's why you want that data flow architecture. And, a lot of that time it took was I/O. We processed 2,600 files, 6,000 files and 2,600 directories, and that's not bad, not bad.
Yes.
Okay, any other final parting questions before we go? Is there anything that you would particularly like to see next time? If you think of something after we shut down, feel free to just go to Discord server in the question, say, could you please talk about blah, blah, blah next time?
Professor, just one thing that came into my mind. A little bit about macros, maybe, because I noticed the print functions and all of they're not functions, they're macros. So a little bit about that.
I will definitely do that sometime. I don't know that I will do it next time. The reason is I've only written 1 or 2 macros, and I don't like to talk about stuff until I have a little more mileage under my belt, because I find sometimes I say things that aren't true if I'm too eager with my presentation. So, but I will definitely talk about it. Do go to the Discord server and just put that in as a reminder for me, and I will definitely cover it. If I have time, I will cover it next time, but I suspect it might be the time after that.
Okay, sure.
Okay.
Yes, thank you, Professor.
Alrighty, guys, I think we're about done, so let's call it a day and do a sayonara, and I'm delighted you are all here to participate, and keep rusting, so everybody's still enjoying this? You're still more or less enthusiastic with Rust?
Yep.
Yes, Professor.
Arpit, how are you doing?
Good. I think
Okay.
I'll need a lot more reading to do this time.
That's okay. Best put on your Superman t-shirt.
I would.
For the rest of you who don't recognize that comment, at final exams and midterms, he would wear a t-shirt that had a Superman logo on it. It was his good luck charm for the exam.
I saw that in one of the pictures.
Yeah, I've got a picture on the old website somewhere. Alrighty, guys, we'll see you. I'm gonna
Thanks, Doc.
sayonara. You bet. If I
Thank
can
you,
figure out how to
Thank you,
get out of here.
Professor.
now.
Thank you.
So I got to turn off the recording. How do I turn off the recording? I can't figure out how to turn off the
Should be
recording.
a record button right at the bottom next to screen share, Doc.